Yeah, start. Okay. So we are differentiating y with respect to x. That's what this means. So it's in fact d by dx. This is a differentiating with respect to x. That's what d by dx of y. So if I write dy by dp, that means we are differentiating y with respect to p. So what it requires is, if we have y is equal to 2x plus 3, because x is the variable, y is the function, we do dy by dx. We do with respect to x. If, for example, y is equal to 2r plus 3, then we can't do dy by dx. We do dy by dr. So the variable is important, and the variable is what we write it here. So in this case, when you do dy by dx, you get the answer as 2 for 2x. For this, dy by dr is also 2 because r is a variable. So that with respect to is the important bit here, with respect to. So in all these questions, first exercise, that's a 6.1, we need to understand why they are saying or what they are saying with respect to what. Okay. So I will start
Yes.
writing. Yeah, I'll start writing the first question from the textbook, and then we will go each question. The first question is, find rate of change of area. This is how the question, rate of change of area of a circle with respect to its radius, with respect to the radius r. So this is the question, and he gives when the radius is, when r is 3 centimeters, and a b when r is 4 centimeters. So we have to
Sir,
understand the
which question is this? Which exercise?
exercise 6.1, page
Okay, sir.
197, page 197. Okay. So the keywords are, these are the keywords. When they say rate of change of area of a circle, then with respect to radius r. So which means we must know the formula for the area of a circle. So we'll say the area of circle is A is area of circle. This is one letter we are picking up, that's it. That's equal to, we know the formula, we must know the formula, they will not give the formula, pi r square. So if he says with respect to radius r, then we have the radius r like this. So he's asking the rate of change. That means how is area changing? That means change of area with respect to radius. That means dr. So this with respect to has become dr. Change of area has become this. The rate means this line. So change of area is this. With respect to is the dr, and the line is the rate. So I'm recording this, I'll be uploading this. Okay. So in case you have any audio problem, you can refer this later. So
Okay, sir.
I'm differentiating A with respect to R. So pi, and for R square it is 2R. That's a differentiation. So you've got 2 pi R. So earlier we used to do only this much. We differentiated and we used to stop. After differentiating, now we should see, he said when r equal to 3 centimeters. So I need to substitute this into this. So I'll get 2 pi multiplied by 3 centimeters. So I'll get 6 pi, 6 pi is the answer. We have to write this as, since we got as a 3 centimeters already, so we just apply this as a centimeters. So this is the final answer. For B, so you just substitute into 2 pi r, 2 pi into 4, that's equal to 4 centimeters. So you got 8 pi centimeters is the second part. So each question, so the key point in this is you must remember the formula and you must remember what is that with respect to, he is asking. Then differentiate. After that, substitute the variable. So these are the 4 steps you must be doing in every question. So the
Okay, sir.
second question is, volume of a cube is increasing. Volume of a cube is increasing at the rate of 8 centimeter, at the rate of 8 centimeter cube per second. How fast is the surface area increasing? How fast is surface area increasing when length of edge is 12 centimeter? That means when the edge is 12 centimeters. So first, as I said, we need to have the formula. What is the formula? Volume of a cube. So V is equal to, so we assume that edge, we know the cube is something like that. So we assume this is x, edge is x centimeters. So each one is x and this is x like this. So the formula is x cube. He has look at the units and what he has already given. He has given change of volume divided by change of time. See, when they say this is a volume change, delta V divided by delta T, or dV by dt is given, is 8 centimeter cube per second. How do we know that? By looking at the units, we understood that this is given. But this is in terms of x. So now, how do I get dV by dt from dV by dx? I have only dV by dx. So you need to multiply with something, then I get dV by dt. So dt, that's why I need to get dt, dx to get cancelled, so I'll put dx here. So we need to first find dV by dx, then multiply dx by dt. Okay, so how do I, what is given in this? This is given, and this can be found out from this. So you get dx by dt. Let's see what I am doing. So dV by dt, 8 centimeter cube per second equal to dV by dx. That means 3x square. I differentiated this. dV by dx is equal to 3x square multiplied by dx by dt. I don't know this. I am writing like dx by dt. So from here, you will get dx by dt, that is this, equal to 8 by 3x square, so many centimeter cube per second, and this is what I have dx by dt. So what is he asking? He is asking the surface area. So what is the surface area formula? Surface area equal to, remember this, we will be taking to the next page. So surface area of a cube, let's call it as A, is 6 times of x square. So he wants to know what is dA by dt, how surface area is increasing. So dA by dt, but the variable is x. So we write dA by dx, chain rule, into dx by dt. dA by dx, that means we are differentiating this. We get 6 into 2x into dx by dt, 8 by 3x square centimeter cube per second. So this is what dA by dt. But he said when the edge is 12 centimeters, now we need to substitute x is equal to 12 centimeters. So dA by dt equals 6 into 2 into 12 centimeters into 8 divided by 3 into 12 centimeters into 12 centimeters multiplied by centimeter cube per second. So first look at all the numbers. This 12 goes 12 centimeters, this 12 centimeters is gone. Then you have another centimeter here that takes off this cube to square. Then we have 3 times 2, so nothing in the denominator. So 8 eights are 64. So units also to be written centimeter square per second. So finally check. So change in the area, so that's why I got centimeter square. Change in the time, that's why I got seconds there. So this is the final answer. Have you understood?
Yes, sir. Yes, sir.
Okay. So now I am going to question number 3. I will probably type it because it's easier to type the question than writing it there. So you will see after some time, after I finish typing it. I'm not sure you will see while I'm typing. The radius of a circle. If you have a textbook, then I don't type.
I don't have the textbook, sir.
That's why I'm typing all the things for you, okay? So that when you refer it, all the things are at one place. So the area of a circle is increasing uniformly at the rate of so 3 centimeters per second. Find the rate at which area of a circle is increasing. The rate at which area of circle increasing when the radius is 10 centimeter. When the radius is 10 centimeter. I will write down. I will write down. Now you are able to see the question, right? The radius of a circle is increasing uniformly at the rate of 3 centimeters per second. Find the rate at which area of circle increasing when the radius is 10 centimeters. So let's underline this is 3 centimeters per second. So you are seeing centimeters per second. It is sum by dt, something by dt. So what is that? Radius of the circle is increasing. So dx, that's let's call the r radius. So this is r, and that's why dr by dt equal to 3 centimeters per second. So this is the last thing. When the radius is, this is the last substitution step. This is substitution. So we have to start with the formula. First one is the formula. So first formula, for what formula we have to look for the area of a circle. So area of a circle A, area of a circle equal to pi r square. So A is equal to pi r square. So formula is done. What is the second one? We have to remember like 4 steps I mentioned, right? I'm just going back to the formula and I have to find with respect to and then differentiation. Okay? So in this case, with respect to. So what is he asking? So he's asking the rate at which area is. So with respect to now, I need to be finding the dA by dt. So let us look at now. The third one is a differentiation. We have to go for the differentiation now. So when I differentiate this, dA by dr equal to pi into 2r. That's equal to 2 pi r. I differentiated. But what we need is dA by dt. What we have is dA by dr. So dA by dt, this is what we need to find, equal to dA by dr multiplied by dr by dt. So we have dr by dt here and dA by dr here. So pick those things from here and here. So this is a dA by dr and this is a dr by dt. Therefore, dA by dt equal to 2 pi r multiplied by 3 centimeters per second. So that gives me 6 pi r centimeters per second. But he said find the last step, dA by dt substitution at 10 centimeters. We write this also as a notation. This is like say at r is equal to 10 centimeters. So we substitute that 6 pi 10 centimeters multiplied by centimeters per second. So the centimeter becomes centimeter square. So you got 60 pi. You don't have to multiply, you can leave it in terms of pi. Centimeter square per second. This is the final answer for question number 3. Find the rate at which, so find the rate at which area of circle is increasing when the radius is 10 centimeters is done. The next question, the fourth question, question number 4, again I'm going with the text. So let me type the text first, then I will come back. So question number 4, an edge of a variable cube, an edge of a variable cube is increasing at the rate of, is increasing at the rate of 3 centimeters per second. So the edge is increasing at this. How fast is the volume of cube increasing? How fast is the volume of cube increasing when the edge is 10 centimeters long? Edge is 10 centimeters long. So this is the question. An edge of variable cube. That means the cube size is increasing. I think there are some spelling mistakes. Increasing, I think there's spelling mistake. Just ignore that. So, so this has been, should have been increasing at the rate of 3 centimeters per second. How fast is the volume? So again, look at what is given. 3 centimeters per second and it is edge. So what we have here, assuming that edge is some x, this is x. So dx by dt, that is given 3 centimeters per second. How fast is the, how fast, the moment we say fast and volume. So I will come back to increasing, decreasing things later. We'll come to that point later. Increasing means positive and decreasing means negative, that's all. So first one is, we have to look at the formula. Which formula this is now? V is equal to x cube. So put V is equal to x cube. Then we have to see with respect to, what is he asking? How fast? Fast is the keyword. So I need to find out dV by dt. Then third one, differentiation. So I go ahead and differentiate this. dv by dx, because it is in x. So I'll get 3x square. So differentiation is done. Then we have to go for the substitution. So before that, what is he asking? dv by dt he is asking. This is what he is asking. So dv by dt equal to dv by dx, that is this, multiplied by dx by dt. So substitute those things. dv by dx equal to 3x squared multiplied by dx by dt is 3 centimeters per second. So this is dv by dt. So we used this already, 3 centimeters. We have to use this. Therefore, dv by dt at x is equal to 10 centimeters equal to 3, 10 centimeters multiplied by 10 centimeters multiplied by 3 centimeters per second. So 100 multiplied by 9, it's a 900 cm cube per second. Have you understood all the 4 questions?
Yes, I understood.
Understood. Okay. Fifth question is, a stone is dropped into a quiet lake. So because these are all applications, you will see something related to what we are actually doing outside and things like that. That's a practical examples. Okay. So fifth question, I type it. Text is there and question number 5. The stone is dropped in a quiet lake and waves move and waves in circles at the speed of, at the speed of 5 centimeters per second. At the instant when the radius of the circular wave is 8 centimeters, and the instant how fast is the enclosed area increasing? A stone is dropped in a quiet lake and waves move in circles at the rate of at the speed of 5 centimeters per second. At the instant when the radius of circular wave is 8 centimeters, how fast is the enclosed area? So in order
Yes, sir.
to, sometimes if you don't understand, then we may just draw a simple picture. So there is kind of water and a stone is dropped. Stone is dropped into this. So you will have, this is how the ripples come. So this distance is what he's talking about, 5 centimeters. So that is how the wave move in circles at the speed of 5 centimeters per second. At the instant when the radius of circular wave is, that means when the radius is, for example, when the radius is 8 centimeters, when it has come up to this, how fast is the area enclosed increasing? This is the entire area enclosed from all the way up to this. That means if you have an 8 centimeter circle, this is the entire area. That's what we need to find out. So going ahead with regular steps, formula, since he's asking about the area of a circle, So A is equal to pi r square. That's a formula. So what is given? So the stone is dropped, wave moves. So waves move is nothing but the radius dr by dt. Also from the units you can see it's 5 centimeters per second. So we do dA by dr first. That's equal to 2 pi into r. Then we say dA by dt equals to dA by dr. That is this one. So we are using both these two. Multiplied by dr by dt. That's equal to 2 pi r multiplied by 5 centimeters per second. So we got 10 pi r centimeters per second. So we need this dA by dt when the radius is 8 centimeters, r is equal to 8 centimeters. So the 10 pi 8 centimeters multiplied by centimeters per second. That's equal to 80 pi centimeters square per second. So this is the fifth question. So far, the questions are easy. Only up to the next question, this is a radius of circle, everything. Sixth also radius of circle and all. Then seventh one is a rectangle. Eighth one is a sphere. Eighth, ninth a sphere. Like that, a different thing in each question. Okay. So,
Okay, sir. Sir, I can't hear you that well now. Your voice is like booming.
is going very low or the voice is very weak?
It's booming. It's a bit muffled.
Muffled, is it? Uh, Now I kept my mic very close to my mouth.
It's
Okay,
better, sir.
it's better. Okay. So now let me type the question. So I have started typing the question. So the question number is 6. Radius of circle is increasing at the rate of zero point 0.7 centimeters per second. What's the rate of increase of its circumference? Okay. So shall I just do the solution? You can read the question from textbook later, or anyway, I'm giving the video of this entire thing. Okay, so I'll type it. The radius of the circle is 0.7 cm per second. So that's the question. Here he didn't. He gave only one data, that is 0.7 centimeters per second. So solution will be dr by dt equal to 0.7 centimeters per second. And he is asking circumference and the rate. So circumference, let's call C, equal to of a circle is 2 pi r. Circumference is 2 pi r. We've got the formula, and what we need to find out is dc by dt. That's the rate. When we say rate, it is dc by dt. So we'll first do dc by dr. That's equal to 2 pi. So dc by dt equal to dc by dr multiplied by dr by dt. So that we will cancel. So dc by dt equal to dc by dr is 2 pi and dr by dt is 0.7 centimeters per second. Therefore, this is 1.45 centimeters per second. This is the easiest question. Seventh one,
Yes, sir.
the length of a rectangle is decreasing and the width y is increasing. So One of a rectangle, something is increasing, something is. So let me draw that and explain that. Okay. So we have a rectangle. The length, this is called length, and he actually names the length as x. So we can't take this as a some L or something like that. So this is length is x, and the width is y. So what he has given is dx by dt is given. That's equal to 5 centimeters per minute. And this is, he said it is increasing. The length of x is decreasing. Okay, that means this is negative. dy by dt is increasing 4 centimeters per minute. Plus. So this is increasing like that, and this is decreasing like this. So something like that, or it could be something like this, whatever. That's what is happening to this. So when x is equal to h, when x is equal to h, and y is equal to 6 centimeters, find rate of change of perimeter. So perimeter d, how the perimeter is changing with the time. So let's call perimeter as p. Let p be the perimeter. And second part anyway is asking area. So A be area of circle, of rectangle, I'm sorry, rectangle. So we know perimeter P is equal to 2x plus 2y, because when you take a rectangle and this is y, this is x, this is also y, this is x. So perimeter is area equal to x multiplied by y. So he is asking what is dp by dt is how much. He is also asking dA by dt how much. So dp by dt equal to, I am differentiating this. I differentiated left side. To differentiate right side, we'll have 2 dx by dt plus 2 dy by dt. So what I did, I differentiated left side and right side. So differentiating left and right side of this. And that's when we get like this. So he said we wanted the dp by dt when x is equal to 8 centimeter, y is equal to 6 centimeters. So do I have dx by dt? Yes, I have dx by dt. Dx by dt is 5 centimeters. What is given was dx by dt negative. Here I am writing number 5 centimeters per minute. This is decreasing. Then dy by dt was increasing at 4 centimeters per minute. This is where the symbols come into picture. So this is minus 10. This is plus 8. So many centimeters per minute. So the answer is minus 2 centimeters per minute. Or you can write that perimeter is decreasing. If you say decreasing, you don't have to put minus. If you put minus, you don't have to say it is decreasing. So that is for the perimeter. Now comes area. We said area formula is this. So dA by dt, we have to use the product rule here. So first we differentiate dx by dt, keep them y constant. Second, keep x constant and divide dy by dt. So dx by dt is minus 5 centimeters per second, sorry, centimeters per minute into y plus x into dy by dt is 4 centimeters per minute. So now I have to substitute x and y. X is 8, Y is 6. So you'll have minus 30 centimeters per minute, centimeter square, because it's of centimeter, plus X is 8, so 32 centimeters square per minute. So you will have 2 centimeters square per minute as the increase the area, rate of increase of area of the rectangle. So that's the seventh question. Eighth and ninth questions are on the balloon. How balloons, that means both are sphere formula we have to use. Okay. So going to the next page. Type in the question. Question is balloon question. Okay. A balloon which is always a sphere is a sphere is being inflated, by pumping in by pumping in air or gas. Okay, so pumping in 900 cc, 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases. Radius of the balloon is increasing when the radius is let's read the question. The balloon which is always a sphere. Actually, balloon is not always sphere. I mean, there will be a different, a little bit ellipse shape. So a balloon which is always a sphere, because for mathematical purposes, he asks us to consider it as a sphere, is being inflated by pumping. So now we have to look at what is given here. What is given here is 900 cubic centimeters per second. So something like centimeter cube per second. So this has to be a volume with the time. So dV by dt is given 900 centimeters. So this is the first step, important step. Then we go for the formula. Formula V of a sphere equal to 4 by 3 pi r cube, assuming r is the radius of sphere. So dV by dt is given, and he is asking find the rate at which the radius of the balloon increases. So he is asking us to find what is dr by dt. So now I differentiate this first. dV by dr, that's equal to 4 by 3 pi into 3r square. So this 3 get cancelled. So we got 4 pi r square. Earlier it was centimeter cube. We will do that actually. So dV by dr is 4 pi r square, not dV by r. Therefore, dV by dt equals to dV by dr multiplied by dr by dt. So this is what we need to substitute here, and we will get this. So 900 centimeter cube per second equals to 4 pi r square multiplied by dr by dt. So that is when the radius is 15 centimeters. So first get dr by dt as a subject equal to 900 divided by 4 pi r square centimeter cube per second. Now we need to get dr by dt at the 15 centimeters. So 900 divided by 4 pi into 225 centimeters square multiplied by centimeter cube per second. So this centimeter square will cancel out this. Now pi is there, 225 is there. So 225 is 25 nines or rather 925. Let's take 9 and 25. This one is 900 sir. Then 100, 25, 4. So this 4 gets cancelled. So the answer is 1 by 5. So you will have 1 by 5 centimeter per second. That's the answer. So
Yes, sir.
the next one is again on the sphere. A balloon which remains always as a sphere, and that's a question. So question number 9. A balloon which always remains spherical has a variable radius. Find the rate at which the volume is increasing. Find rate at which volume radius is 10 centimeters. So this is the question. The balloon has a variable radius. Find the rate at which volume is increasing when the radius is 10 centimeters. So obviously we need to find out the volume. So I need to know the formula for the volume of balloon or the sphere. So first thing is volume is 4 by 3. V is equal to volume 4 by 3 pi r cube. And what we need to find out is dV by dt. So dV by dr multiplied by dr by dt. This is what we need to find. So when I differentiate this dV by dr, 4 by 3 into pi into 3r square, 3 gets cancelled. So we got 4 pi r square. So dV by dt equal to dV by dr 4 pi r square multiplied by dr by dt. So now find the rate at which the volume is increasing with radius. I think he mentioned another thing, volume is increasing with radius. So when he says with radius, we just need to find out dV by dr. We don't need dV by dt. dV by dt is not required because it's with radius. So dV by dr is with radius. And now we directly substitute dV by dr. R is equal to 10 centimeters. 4 pi multiplied by 10 cm. That's equal to 405 cm square. So that's how the volume is increasing with radius. Question number 10. This is important question. Question number 10. They are given 2 times. One in it was given one in 3 votes or one in the sample papers, and in the final exam also 2015 or 16 probably. This question was given. So that's important question.
Okay, so
One second. So question number 10. Ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled. The bottom of along the ground away from the wall, away from the wall at a rate of 2 centimeters per second. How fast? Its height. The ladder is actually falling down height on the wall. On the wall, decreasing, decreasing. And the foot of the ladder 4 meters away from the wall. So there is a question. A ladder 5 meter long is leaning against a wall. So you have a wall. So like this is there. This ladder is 5 meters. The bottom of the ladder, that means this part, is pulled along the ground away from the wall. That means it's moving like that. The ladder is becoming like this. So this, there is an increase on this side and there is a decrease on this side. So let us consider first by drawing the picture, and let's consider that this is the right angle triangle. So this is the ladder, and let us call ladder length as a L. And this may be X, this may be Y. So the length of the ladder is given. So this is 5 meters. That's what we are taking care. Then at the rate of 2 centimeters per second, that means this one dx by dt, it's increasing. That's why it's a plus 2 centimeters per second. How fast its height on the wall decreasing? So we know that dy by dt is asking. So we need a formula. What is the formula we can get with the L, X and Y? L square equal to X square plus Y square. This is what a Pythagoras theorem, and so we put that L square equal to X square plus Y square. Now differentiate this. Differentiate left side, right side with respect to t. Why? Because he's asking again how fast. That's why we want to do it. So here you get 2L into dl by dt equal to 2x dx by dt plus 2y into dy by dt. He has given x is changing, that y is also changing. But do you think length of the ladder changes? No, right? Length of the ladder is a fixed one. So dl by dt equal to 0 because ladder doesn't change, ladder length doesn't change. alpha is not changed. Therefore, the left side becomes 0. So you will get 0 equals, because of this, 2 also can cancel. 0 equals to x dx by dt plus y dy by dt. So 0 equal to x dx by dt plus y dy by dt. So we need to find this. We have this, and let's see what else we have. So 0 equal to x into dx by dt is given, y into dy by dt we need to find. So going back, dx by dt is plus 2 centimeters per second. So this is 2 centimeters per second. Now how do I get x and y? So L is equal to 5, we know that 5 meters. Observe the units also, okay, 2 centimeters per second. L is 5 meters. And he said when the foot of the ladder is 4 meters away from the wall, that means he has given x is 4. X is 4 meters. This is also given, both are given. So using the formula y square equal to x square minus x square, same Pythagoras formula, we can get y is equal to 3 meters, 25 minus 16. So y is equal to 3 meters. So substitute x and y into this. 0 equal to x equal to 4 meters into 2 centimeters per second plus y 3 meters into dy by dt. So now whether we convert any units or not, don't convert anything. Okay. So take this to the other side. Then you get minus 8 meters into centimeters per second equal to 3 meters into dy by dt. First thing, cancel this meter, cancel this meter. So you will have dy by dt equal to minus 8 by 3 centimeters per second. Therefore, height is decreasing at 8 by 3 centimeters per second. When we say decreasing, we don't need to put line. Hmm?
Okay, sir.
So this where we can stop today. Um, I will be uploading this onto the YouTube. Okay, today's class.
Okay,
Okay,
sir.
so you can do that. We will continue. We have to complete this exercise and on Wednesday. We'll be completing on Wednesday. Wednesday, I will take a PDF and then put it onto the. I will don't write the questions. Okay, because I was not prepared today for the PDF. Wednesday, I will get the PDF and then put onto the screen. All right.
Okay, sir.
I won't send any message on Wednesday also. You can just log in by 4:30. All right.
Okay, sir.
Okay. Stopping the share and stop
Thank you.
recording.